Hello and welcome. Today I'll present my arena simulation model. Let me actually get it started. Yeah. Um, which is for Manu 1420 Project A. This model simulates passengers flow within the airport departure hall, capturing their movements from the entrance to their designated gates. So let's get started. The simulation runs from 12 hours for 12 hours from 9 a.m. to 9 p.m. After 9 p.m., a new passenger are no longer allowed to enter, but those already in the terminal continue to their gates. The goal is to study the passenger flow, identify bottlenecks, and understand how resources are used throughout the day. Um, so when it comes to the passenger characteristics and movements, passengers arrival. So let's talk about the passenger arrival and gate assignments. Passengers arrival at the terminal with the inter-arrival time following the next 45, as you can see in here. Actually, I need to stop this a little bit. Yeah. So as you can see in here, um, and when we go in the distribution, so as you can see here, this is district distribution with 0.3, uh, 0.6 for index 1, 0.6, and 0.3, which means 30%, and then the other 30%, and then 40%. So for gate 1, 30%, for gate 2, 30%, and then uh, for gate 3, which is the completion between 0.6 and 1, which is 40%. So this is the distribution that we are featuring. So this is the feature. And also there's another feature, which is the types of passengers. We know that there's a leisure travelers, which are 70%. And then there's the business travelers, which are 30%. And this explain it, the passenger type of index. So with the business or the leisure, we are putting 70% in here, and for the business, we're putting the other 30%. Uh, and this is pretty much the passengers type index. So this would be an input to this attribute. And then there's another attribute, which is the first arrival time, T now. So when they first arrive, we put counters because later we'll have to count the average time that the passenger takes from the second he enters to the second he reach the gate. So we have to use this feature. And yeah, this is how we done it. Um, Even there are some walkaways, the speeds for each one is per second, per meters per second. Um, yeah. Also, so basically here is just checking the leisure or uh, business. So here they have a different speeds, and that why we have uniform 2 or 3. Uh, and here for the business, it's quite different. They they would take less time because this is pretty much what happens at the airport. And so from the requirements, then they enter the station. As you can see in here, let me simulate it really quick. So yeah, you see that they all are going in, and then they have the conveyor, right? And then they jump to the dining area. So you could see that some travelers are sometimes going a little bit faster than other travelers. I actually might have to slow it a little bit, but it depends on the probability. But here again, if it's true, two-way distribution, leisure. So most of the travelers would go a little bit slower in the business speed, and then they go into the conveyor, and then they enter the dining area. So when it's come to the dining area, there's a possibility, two ways possibilities. According to the requirements, uh, about 20% of passengers stops at the food court. Uh, this involves the three steps: browsing for food with TRA, which is uh, distribution for either 4 or 7 or 10 delays. We can see, yeah, these are just counters. Sorry, here's the food counters. We can see the three TRIA, which is delay of 4 or 7 or 10 minutes, random. So, and then these are just the requirements. And then they bring at the cashier, and we can see that they enter the food court entrance, they stand for there for delay, and then this is a release. That why it's store in and store out. Uh, and then they enter the cashier, as you can see in here. Yeah. Uh, Again, so staying with the cashier, there's sometimes there's 3 cashiers, so maximum of 3, and then there's the delay of 1, 2, and 3. So you can see the distribution based on the requirements in here, 1, 2, or 3. Then we have the resources, the cashiers, and then they exit the cashier area, as you can see in here. They go into the dining area, they enter the food cart. Uh, and for that, we have the following TRIA feature of 8 seconds or 28 seconds or 40 seconds. Uh, yep. Then they leave the food cart. Uh, so these steps help simulate the time spent in the food court and highlight the potential delays before boarding. Also, the gate boarding process and FIFO configuration, which is first in, first out. So each gate operates within the FIFO system, meaning passengers are served in order by their arrival. Uh, the boarding takes 1 to 3 minutes within TRA 123. We can see the gate boarding in here. Uh, right? TRA 123, which is triangular type. Let me illustrate that. Okay. So the delay is triangular type. It could be one, it could be two, and like this is the most likely, and then the maximum is three. And then when we go to the cutoff mechanism, basically, yeah, let me just run you guys really quick first. So there's a 20% possibility to go die. So true, 20% true, and most of them won't die. And that is clearly shown in the illustration. But I'll try to okay do it really quick, make it a little bit faster. Yeah, so most of people don't pass through the dining, but a good portion of them does. Like not a good portion. Finger crossed if they are like 20%. And then when they enter food court, this I explained this uh before. So eventually, and this clearly shows why I'm taking this approach, because once they exit, everyone is exiting. They have eventually to go to the gate station, which wasn't the requirements. So once they go from the gate station, they could go to either gate 3 straight away, or this conveyor, which will take them based on the requirements still, which is gonna take them through gate. So it's like two roads, sort of roads. It's either three or two and three together. This is two, and these are from the requirements. So, and this is shown here. So the gate station, then you decide to go to gate three or gate one and two. And I said, as I said, like the actually the requirements, uh, the possibility of gate uh three is, hold on, let me check the ones. Yeah, so the gate is 40%, and that why we could see that still this conveyor is taking them to 1 to 3, which is 60%, and this is like 30%. That's explained, and this still like the simulation hasn't yet finished. Pretty much it's gonna finish soon. But you can see that the possibility of people are going to road one are uh less, but still two-thirds of this, which is 40% pretty much. Yeah, so once they go to road one, okay, uh the road one is basically just connecting this. If you can see, let me stop this simulation. So they go straight away to the gate 3 station. So route 1 is connected by uh, gate 3 station S. And this explains why they straight away jump to the gate 3. While for the people going to gate 1 and 2, they go to gate 1 and 2, as you can see. They are after gate 1 and 2, as you can see from the simulation. Once they go from one of these gates, as per the requirements, okay. Uh, there is still possibility of them going straight away to gate 2, which is exactly in the gate stations. So
This decided block will use the condition of gate number attribute. It's equal to 1. Uh, then it will go to true, which is gate 1. Otherwise, it will go to gate 2.
once they go to gate 2, they just go straight away to boarding, and then we put this function to count because we need to eventually get the average timing. And this is good approach to think of when you're actually into airports and you want to count how long does it take passengers. So this simulation is really great, really simulating real life context sometimes. And then they go eventually to gate 2. Uh, yep. But if they want to go to gate 1 now, they have to go into the routes. Route 2 is just it's a little bit different because you see the station is gate 1 is straight away here. They can go to the borders. But if they want to go from break route 2, they have to go all the way and walk for, as I remember, 70 meters. Yeah, if I wasn't sure. I did according to the requirements. You can check it out, but they had to walk for a certain distance. And then once they finish that, they go to the gate station, and then they do the gate boarding, similar to these approaches, uh, gate time counter, sorry, and then they go into the gate. So yeah, I think this is my simulation. It's not that complicated. The cutoff mechanism, um, it's a slightly different. So the key feature of this model is the cutoff mechanism, which activates the 9 p.m. at 9 p.m. This stops a new passenger from entering the terminal while allowing those already inside to continue in their gate. This ensures realistic end of day follow where operation completes smoothly. Um, so basically, we've maximized the time and then we put it for 12 hours. So it runs once uh, after 12 hours when we start the simulation, which is gonna be 9 p.m. So once we start the simulation, it's 9 a.m., right? And then after 12 hours, which is 720 minutes, it's 720 minutes, it's gonna do this cut off, or like, okay, we gotta enter a new arrival, and then we have the max arrival of one. So it's it's another create block, and we can see assigning a variable for cutoff. The variable where arrival are zero. So and we can't put this one. So the max has to be one pass. So now there wouldn't be any new passengers entering. Uh, and then yeah, we just called this one cutoff. So uh, this uh goes into there, and then it's just straight away after 9 p.m. It's cut off because it's starting to get that passenger in, sorry, the order in, and then no other passengers would enter. I hope it's explained. Uh, it's not really my thing explaining things. Anyway, so uh, yeah, this is how it works. Most of them are going in. Um, I'll just hop into the animation real quick. So you can see here, uh, hold on, let me go to the, I have to stop it, right. Okay, run. If we go into the animation resources, uh, so basically I had this passenger, this passenger, this passenger, and this passenger. So those were my passengers. And then uh, I brought this one from the internet to be like the food counter where the passengers pick their food and then they go into uh, hold on. Yep. And then okay, let me just enter one of these. And then they go into the cashiers and like there are three cashiers, they can go straight away to them. Also, as you can see, the passengers are lying here and the passengers are lying here because if they are maximum, like they, it should say busy. Let me just run it again really quick to explain that. Oh, okay. So let's make it a little bit faster. Yeah. So it's busy with some people, but it's not gonna happen that often that it's gonna be full. However, if it's full, people gonna align in here because there are three cashiers. No one is I don't know if you caught that, but some people are aligning there. Uh, and then once the passengers move, they eat. They sit in the dining area. Again, it's just 20% of them. And for each gate, there's uh like a boarding team, two people boarding the passengers. Red project B, we're gonna do a little bit more, but for project A, this is pretty much summarize it. There's a potential use of Arena in the future, especially uh, in my animation. Beyond this project, Arena can be applied in many industries like manufacturing, healthcare, and services sectors to model and optimize complex processes. Its versatility makes it valuable for any scenario that involves managing the flow and resources because it has wide variety of options. We simulated the time, like if you guys go through this one, the instructor goes through this one, you could see how many features I put in there and adapted to everything, even like the speed, you can play around the speed. I made the leisure a little bit slower, sorry, yeah, faster than the business. I don't know, I don't remember the requirement, but one of them was faster than the other, was great. So in summary, this model captures the journey of passengers through an airport departure hall, showcasing areas like food courts, boarding gates. By analyzing this simulation, we can identify inefficiencies and find ways to improve operation. Thank you for joining me for this walkthrough. I hope I explained well. I'm not that good in explanation, but I'm really good at at Arena. I love it. See my work in here. I've tried to share most of it. Yeah, thank you for your time.